Okay. Hello, hello. Let me see, why isn't my image coming up here? So yeah, you guys had PSAT yesterday primarily. But I think, didn't we still have, what was it? I think we had some homework the night before though. So we'll have a look at that if you guys have any questions on that stuff. And then we're going to look at our last lesson for this chapter, which we aren't going to have a quiz specifically for this lesson, but it is going to show up on the test just to save time. So we'll be able to do that. Let me see, why isn't my stream... Ellen says this makes no sense. Excellent. Let's figure out if we can narrow down what aspect doesn't make sense. Let's see. Show mouse pointer. Am I getting a mouse pointer? No mouse pointer. Select capture area. Do I have to reselect? Let me see. Where's my... Sorry guys, just getting this going here. Sketchbook should be working. This screen, confined to application window. Here it is, Sketchbook. Okay, nice. Alright, so you guys can see my mouse, and hopefully the background there, it looks like it's transmitting, and no frames dropped. So good. Alright, so welcome back guys. Hopefully PSATs went well. Let me know what you'd like to go over from the previous lesson. Let me actually open what my subplans were, or better yet, what was on the curriculum map. Oh, I gotta reconnect here. Oh, oop, darn it. Choose a different account. So yeah, I've got my textbook here. And what was it? Were we still on parabolas back then? I'm trying to remember. Or was it on transformations of conics? Subplans. Oh, right, we just had the quiz the other day. Okay, so actually that's one of the things we can do. We do have a review day scheduled for Monday, but I can go over some of the quiz now with you guys if you want. Obviously I didn't grade your quiz, but I can go over select questions. So I can't let you guys like take your quizzes back, obviously. But if you have any questions on parabolas and whatnot, I would gladly go over some of those. And let's see, oh, I just clicked that. And let's see, oh, right. So last night's homework was CUDA writing equations of parabolas 1 to 11 odd. Yep. Oh, so these were all the hints ones. I like those kind. And let me see, my chat channel's hiding right now. Let me see if you guys are talking to me. All right. Okay, wait until the quizzes are graded first. That makes sense. I am going to be coming back probably like Saturday night, so I'll end up trying to have the quizzes graded for Monday, and we'll be able to do that. But do you guys, is Ellen having questions about systems of conics from today? Because you guys didn't try that earlier, did you? I think I did have it scheduled for yesterday, but then I didn't realize how significant the PSATs were going to affect our class. I didn't process that at the time. So I apologize if you ended up trying to do that last night, but your original Wednesday assignment that I emailed you is what we're going to cover today. So don't stress out. We'll actually do like a little mini lesson today on that. So we tried to take notes today and we are still confused. Yes. Excellent. All right, so let's start there. I'm going to do an example right from the book then, from 10.8. You might have noticed I skipped 10.6 and 10.7. I was considering doing 10.7, and I changed my mind on Monday morning. We're actually going to do 10.6 and 10.7 in pre-calculus once we do some more stuff with trigonometry. And parametric equations is 10.6, which is basically motion of along a curve. Now let's see, why is my writing wrong here? Systems of Conics is what I'll call that. And if you actually look at the curriculum map, I think it's also found in some of the other textbooks that we have in the classroom. I think the Algebra 2 text has a set on it as well. So it's just like systems of equations, except now our equations are not linear, where we've got two lines and we're trying to find the intersection. Our equations are now, an ellipse and a hyperbola, and I'm looking for the, intersections that they have in common. So we can have more than one solution. It's possible to have no solutions. For instance, if I'm looking for the intersection between two ellipses, I could have them intersect like this. I could have them intersect tangent to one another, so they could have a single point. They could intersect, at 4 points. I think I can even get 3 points if I had it like tangent there and then hitting those. And then obviously it's also possible to have no solution if I just happen to have two ellipses that never touch each other. So that's kind of what we're going to be looking for, is what are these solutions between two systems of conic sections. Our methods are going to be primarily substitution and elimination once we have the equations written. So in general, that's one of the first concepts I want you to think of, is how many solutions can there be? And to consider that, I actually literally do draw pictures. So I think on the test, I will have a question like, all right, how many intersections could you have between like a parabola and a circle? And then you just kind of figure out okay, could I have 2? Could I have 4? Could I have 3? And try to figure out how many ways that could occur. Could I have none, right? And yeah, certainly we could have none. So that sort of basic analysis of it is first required. And I'm assuming you guys are okay. It looks like on page 679, there's some nice little sketches there at the top of different types of solutions that we could have, numbers of solutions specifically. But let's actually look at the example on 679, example 1. I'm assuming you guys already kind of wrote it down. So we'll start there, but we don't have to just do examples from the text. So this is example 1 on 679. And we'll take a look at this first, since I'm assuming you guys were just looking at this problem. So 9x squared plus 25y squared equals 225 is our first equation. And then my next one is x squared plus y squared minus 2x equals 15. Right. So what I've got here is, once again, two equations, two unknowns technically. But sometimes the x squared and the x terms will be deceptive and throw us off. So what I'm going to do is try to solve for one of these variables at a time. In this case, I think I'm going to try to solve for the x's. I believe this is what the book does. They choose to use elimination and multiply this second equation through by negative 25, because notice that's going to give us opposite y's. And if I can eliminate the y's, then I'll have an equation in terms of just the x's, and even if it's a quadratic or whatever, I still could solve that equation. And actually, just before we get to that point, I just want to look at these two equations. So this first equation, I just want to point out, notice our coefficients of the squared terms are different, and the signs are the same. So this first equation is actually an ellipse, all right, just to practice kind of our recognition of conics. Our second equation, notice these coefficients are both the same and the signs are the same. So our second equation is actually a circle. All right, so I just want to point that out. So that sort of analysis is beneficial to have. This negative 2x term is basically, if I was to write this in standard form, I'd have to complete the square for the x's, And essentially the center is not going to be at the origin. Although the y-coordinate for the center would be like a plus 0 all squared, right? Something like that. But the x-coordinate is not going to be 0, is what that term will affect. So let's simplify this. So that's negative 25x squared minus 25y squared plus 50x equals, and 25 times 15, let's see, I'm going to steal that data right from the book. I'm assuming they did that. Is that 375? Or no, 225. 375. And it's negative, but I'm opening up my calculator right now. Here we go. So negative 375. So now what I can do between this equation and this equation is add them together, and I'm going to eliminate one of my variables, specifically the y. So I add them together using our regular elimination approach. 9 and negative 25, that's going to be what, negative 16x? Come on, my computer's lagging on me. It's messing up my writing here. It's just because I'm opening the calculator right now. Negative 16x squared. The y's, 25 and negative 25, cancel out, which is what I wanted. There's no like term for the 50x to combine with, so that's just going to be plus a 50x. Equals, and 225 and negative 375 currently combine to be negative 150. So what I'm left with here is a quadratic, and it's all in terms of x, so this is something we can solve. And typically the way you solve quadratics is setting it equal to 0. So add 150, add 150. And the book doesn't show this part, but I'll show it to us just so we get the practice. So this is negative 16. I don't want yellow. Where's my orange? Negative 16x squared plus 50x plus 150 equals 0. And as a matter of fact, I might just go through and change all the signs. I could even technically divide through by a common term. It would change the steepness of our parabola that this represents. So like graphically speaking, I'm just looking for the x-intercepts. So it doesn't matter if I change my parabola by dividing or making it shallower. I'm just looking for the x's right now, so I actually don't care how I come across that answer. So we could make this simpler. I'm going to divide everything through by something negative, first of all, just because I like having my a term positive. And what goes into 16, 50, and 150? Well, at least 2 does. 2 goes into 50 25 times. I think 2 is the best I can do, isn't it? I believe so. 16 is a power of 2. The other factors that go into 50 are what, 5s. So that wouldn't help us. But we'll be able to simplify this a little bit. So this is going to be 8x squared minus 25x minus 75 equals 0. And I don't believe this is factorable necessarily. No, it looks like it wouldn't be. So we'll use the quadratic equation. So a is equal to 8. B is equal to negative 25, C is equal to negative 75, and I'll get x equals, so I'll write down the whole equation. This is what I'm plugging it into. X equals the opposite of B, plus or minus the square root. Okay, I'm sure Ellen is wishing that I'm singing this right now, and considering I'm in an office by myself, why not? So here we go. So x equals the opposite of B, plus or minus the square root of b squared minus 4ac all over 2a. Wow, that was amazing. Why aren't I getting any comments from the chat for that wonderful, wonderful song? But so that's our quadratic formula, or the equation rather. No, I was right, formula. And I'm going to now plug in a, b, and c and just evaluate, it's kind of nice. It does the work for us. So here we go. So we got x equals negative 8 plus or minus, encore, yes, negative 25 all squared, right? Plugging in for b, I've got the negative 25. Very careful with my parentheses, because if I don't have parentheses, I would get a negative value here, but this is in fact going to be positive. minus 4 times 8 times negative 75, all over 2 times 8. So let's see, to simplify this, where did my calculator go? Here we go. I don't have my calculator showing up on your guys' screen. Where did I mess up? Oh, thank you guys, you're the best. What did I do? Was it where I was plugging in there? Or did I mess up earlier? Let's see. Opposite of B. Oh! Wait a minute. Wait a minute. Wait a minute. Right here, isn't it? Aha. Yep, you're right. You guys are the best. Saving me potential errors. Yep. Negative 25, plus or minus. Thank you. So, simplifying this down a little bit, x equals negative 25 plus or minus the square root, 25 squared, negative or positive, will be 625 minus, well, negative and negative is going to be plus, I know that much. Let me pull up my handy-dandy calculator. Man, you guys are so good. You saved me again because it was the opposite of negative 25. I'm so glad you're listening. Really makes my day, guys. So let's see. 4 times 8 times 75. Oh, my 8 didn't show up. 8. What is going on, calculator? You're really messing me up here. 4 times 8 times 75 is 2,400. Yeah, so this is positive, I agree. And I'm getting 2,400 here. Is anyone doing this math with me? I know you guys are catching my other mistakes. So x equals 25 plus or minus the square root of, what's that, 3025? That feels perfect squarish, but I know that it isn't. And I'm going to get, let me see, I'm using my calculator again. Second square root of 3025 equals, 55. Oh, so this problem was factorable, actually. So 25 plus or minus 55 over 16. So I get two possible answers. 25 plus 55 is 80 sixteenths. And 25 minus 55, what's that, negative 30 sixteenths? Did I do that right? And 80 sixteenths, does that divide to be 5? 5, 50, 60, yeah. So this is equal to 5, so there's one of our answers. And this one is equal to, both of those are divisible by 2 at least, so negative 15 eighths. And I think I'm right. So, first of all, let's think about what does this represent? So graphically, all the way back up to the top, remember I've got an ellipse and a circle. So I have at most 4 solutions occurring from that. So I've got like a circle, and let's say I've got an ellipse. In this case, it's a vertically oriented ellipse. Notice I knew that because the y, actually I'm wrong. Technically it's horizontal, but whatever. So imagine I've got something like this, right? Little Saturn planet here. What I've just found out is that these x coordinates and these x coordinates, notice I've got 2 sets, and I wouldn't be surprised that these 2 could be the same and these 2 could be the same. But what I've found out here is that the x coordinates of those points, 2 of them are at 5, likely, and 2 of them are at negative 15 eighths, likely. So that's what's actually occurring is, let's say both of these points have 5 comma something, and let's say this point has negative 15 eighths comma something, right? And the same as this one. So that's what's occurring. So I'm not surprised that I could have more than 2 possible values for x. Now what that means I'm going to have to do, though, however, is I have to consider both cases, because this one's going to have a particular y coordinate, and this one's going to have a particular y coordinate. And it's possible I might even get 2 y coordinates for each of them. And that's what's going to be graphically occurring, is I could find a y coordinate here and a y coordinate here, a y coordinate here and a y coordinate here. So graphically that may be the case that I have as many as 4 solutions. Technically, it's also possible that I just have a picture like this, and maybe I will only find 1 coordinate for each, something like that. So I'm not entirely certain just yet. So what I'm going to do is I need to solve for y, and for both cases, so I want to plug these x's into an equation that had the y in it. And so that's probably using this equation right here would be my best bet. Actually, let's see if I can even be sneaky. No, it's not going to fit, is it? And bam. Let's see if this works. So I don't have to memorize it. Paste. It's thinking. There we are. So good enough. So this is what I'm going to plug in, plug those x's in for. And so let's plug in 5 first. So let's consider that case. So I'll plug in 5 for x, solve for y. And classic algebra, plug in what we know, solve for what we don't. So 5 squared plus y squared minus 2 times 5 equals 15. And I'll get y squared. This is negative 10. This is 25. So that's a total of 15 equals 15. Wait a minute. So I'll get y squared equals 0. And then both my solutions actually appear to be simplifying to be just y equals 0. Because the square root of 0 is plus or minus 0, but really I'm getting 0. So far I've found out I've got one solution at 5, 0. Where should I write that? I'll write this right here. 5, 0 is the first solution. The second solution I'm going to get, or maybe there's 2 more solutions, I don't know. I'll get when I plug in negative 15/8 into that equation. So I'm all the way down at the bottom of my worksheet. I'm going to have to scroll back up and let's see, paste. There we go. A little scribbly there, but that's okay. And so now I'm going to plug in negative 15/8, and being very careful when I substitute that I use parentheses, just like Indiana Jones putting his bag of sand on that little pedestal. He put the sand in a bag, right? He didn't just throw sand on the pedestal. That would have just messed everything up. So I like to think of my parentheses as being like a little bag of sand, right? So put what you're plugging in parentheses. So let's simplify this. Negative 15/8 all squared. First of all, it is going to be positive. There we go. All right. 15 squared, I think, is 225. 8 squared is 64 plus y squared equals. Here the minus signs cancel. Let me switch colors here. 2 goes into 2 once, into 8 4 times. So I can simplify, cross cancel, as they say, and that will be plus here. Sorry, not equals. 15 fourths. All right. And equals 15. So let's see. Now I'm going to get the y by itself. I might as well work towards a common denominator for these before I move them. Looks like 64 is what I'll have to work with, because this doesn't reduce, I don't think. No. 15's factors are 3 and 5. 8's factors are all 2, so that doesn't have any common factor. So I'll multiply this one by 4 times what is 64? I believe it's 16. And this I'd have to multiply by 64 over 64. And I'm going to bring it all together. So I'll get y squared equals 15 times 64. That sounds like a problem for a calculator here. 15 times 64 equals, and I get 960. 64ths. Let me give myself some room here. Right, so that's this term. And then I'm going to subtract these two, right? So I'm actually going to represent that well. So I'm subtracting this guy from both sides, right? So just imagine what I'm subtracting. Bam, bam, right? Save our time not rewriting that. So I'm going to subtract 225 64ths. And I'm going to subtract this thing, which 15 times 16, what's that going to be? 56. Is that going to be 240 64ths? I'm going to check on my calculator. 15 times 16, 240. Good. So now I can just simplify all these. As a matter of fact, the subtractions, for some reason, always more work for me than the multiplication. So let's see, just to avoid errors, because I usually do. 960 minus 225 minus 240, because now that I have like denominators, I can just subtract those numerators. I get 495 64ths, which actually, that doesn't reduce in its current state, because 64 is all powers of 2, and 495 is not even, so I know that it won't break down. But now what I can do, however, is a root both sides, plus or minus, don't forget it, and I will get y equals plus or minus, the denominator square root of 64 is 8, so that's nice, and the square root of 495, does that break up into any perfect squares? So what I'm thinking of right now is 495 divisible by 2? And no, it isn't. Is it divisible by next perfect, sorry, wait, 2 is not a perfect square. I would have asked 4, which it's not. Then I would have asked 9, and I'd say maybe. So I'm going to check that on a calculator real quick. 495 divided by 9. It does. Aha. So it breaks 9 here and 55. And 55 is 11 and 5, both prime, and neither of them perfect squares. So that doesn't break down any further. So I get plus or minus 3 square roots of 55 over 8. And that's my y coordinate when x is this. So that means my solutions for this graph are, what was my first one? 5, 0. Then I've got negative 15 eighths, comma, 3 square roots of 55 eighths. And then I've got negative 15 eighths, comma, 3 square roots of 55 eighths. Let's see. And yes, fortunately that's what the book had. They agree with me. And the book actually does have a little sketch on page 679 now that I just noticed it, which I'm glad, because I was just going to take like 10 minutes to graph this. So notice, yeah, it has 3 intersections, the way that ellipse and that circle happen to hit each other, which is kind of interesting. So, yeah, that's a whole lot of work for that one problem. But it's an interesting one. But the general idea is solve for one of your variables, and it's very possible that you'll get multiple solutions, and then solve for your other variable considering both of your original first solutions. So the overarching process is what's going to be important. I don't have the study guide from 10.8, but I know you guys do. I don't know how good it is in explaining this as well, but it might kind of have a nice little overarching process written there. Sometimes they do. Now, instead of doing another example from the book, because I don't know, I'm not going to have you guys do the systems of inequalities part from example 3. I could see that being confusing. And example 2 actually has... Example 2, it has one of the equations. What is it? What did I see? XY equals 2700, which actually this equation is a hyperbola, and we haven't talked about those yet, but it's actually a hyperbola that looks like this, where your asymptotes actually are your axes. And I think this point is whatever the square root of 2700, comma, the square root of 2700 is something like that, is how you can find like your vertex. And this vertex would be this negative square root of 2700, comma, negative square root of 2700 is your other vertex. So if you imagine your box, like your box would have looked like this, right? Not quite, but you see what I'm talking about, where our asymptotes would end up having been the axes. So it's this weird 45-degree tilted hyperbola. And if this was negative, then it's just tilted in the other direction, like that. So know that in general, but don't go super crazy trying to do that. Let's see. What if we do one of the problems from the practice 10.8, the one that your classwork is right now? Let's see. Looking at problem 1, I see that there's no real solution to that one. That one's not that interesting. So between 1 through 4, are there any of those that you'd like me to do with you? Or we could even look at tonight's homework, which is on page 682, 13 to 19 odd. I'd gladly do one of those with you guys as well, unless you just want a fresh example as well. What do you guys think? Thoughts? I'm hoping you guys can still hear me. Looks like I haven't dropped any frames. Or do you want me to just pick another problem that won't be from your classwork or homework? I don't know if you guys have already started one and we're having difficulty on it. Hold on 1 second. Nice. I'll grab a drink of water. Aha, here we are, page 682. What's that, number 13. You guys got it. I've been quite pleased so far how, number 19. Oh, you guys, you jerks. Alright, we'll do it though. 682. Number 19. Yeah, what I was saying was I've been quite pleased so far how this whole streaming thing's working. I think it's worked pretty well. I mean, I don't see how you guys are doing in class, obviously. Hopefully you're still getting your explanations well enough and understanding this to some degree. But it gives me confidence for next semester when I'm going to be on paternity leave, that I'll be able to teach from home a little bit and then swing by to each class like once a week in person and just see how things are going. So I'm very hopeful, I guess, that I'll be able to keep everyone up to speed at that time. All right, so let's consider this system. So this first equation, this appears to be a parabola. And the reason I suspect that is because I've only got a single variable being squared. There's no x's that are ever going to be squared in this equation. And because it's the y that's being squared, I'm actually expecting this to be a horizontal parabola. Okay? Oh, I just moved my little brush palette there. And this equation, I would hope that you guys could recognize is a line, right? I could solve for y even, y equals negative x minus 1. That would be a very nice equation of a line. So I'm looking for, and it's actually a really good idea to kind of like analyze these problems in advance, gather as much information as you can before you just start attacking the problem and doing math, because it might give you some insight into what you're expecting from your answers. And that's actually something that Common Core expects of students as a mathematical practice, is that you can understand, you can determine the reasonableness or reasonability, reasonableness of an answer when you write it. You kind of try to look at a problem and generalize and think in advance kind of what's going to be taking place in this problem. What sort of numbers would we expect as outcomes, or how many answers would we expect? So that's kind of a skill that I want to kind of keep encouraging in you guys. So let's deal with this parabola first. What I'm going to do is expand this, kind of like the line it up step in Systems of Equations. I think that it might be helpful for us to do that. And if I expand this, then I'll be able to have like a y squared term, my y term, and line everything up compared to the 2. So when I expand that, I'm going to be using this pattern, a minus b, all squared is equal to a squared minus 2ab plus b squared. And let's plug in a and b. A is y, b is 1. And I'll get y squared minus 2 y, I guess I'll write this out, 2 times y times 1. Yeah, b is going to be, positive 1 in this case, since the minus sign is already included in this pattern. Plus 1 squared equals 4 plus x. And keep simplifying here. And I'll get y squared minus 2y plus 1 equals 4 plus x. And let's actually line it up with this. So I'll bring all my variables to this side, and I'll bring my constants to the other. So what I'll do is subtract 1, subtract 1, subtract x. And I'll get y squared minus x minus 2y equals 4 minus 1 is 3. So my two equations, I'm going to rewrite the other one, was x plus y equals negative 1. So now if I want to solve this, I just want to point out, I could try to get rid of these y's, right? But I just want to have us think ahead, what good would that do if I got rid of those y's? Well, I'd end up with an equation that's in terms of y squared and x. So that actually wouldn't help me too significantly because I'd still have an equation with two variables in it. So I'm thinking it's probably a better choice for us to get rid of these x's. Yep, I'll slow down. I'll take a moment for you to catch up if you'd like. So all I've done so far is simplify this equation, right? Simplify that equation. And I'm planning on getting rid of these x's because notice I'd then have an equation in terms of y, a single variable for a single equation that I would know how to solve. So if I want to get opposite coefficients for the x's, it looks like the least common coefficient would be 1. So what I'd end up doing is multiplying this equation by negative 1, because that will give me opposite x's, which would be great. So, and by the way, guys, this video will be available on the stream. I think they keep it up for like 2 days after. So if you do end up wanting to like look at your, when you're doing your homework, rewatch this, hear me sing a song for some reason, or capture that song, say to YouTube, and embarrass me forever, that's definitely an option you could do. So negative x minus y. Oh, guys, I'm so crazy. You're right, they are already opposite. Duh me. So, yeah, I don't, what am I talking about? Those are opposite. Why would I multiply by negative 1? Very good question. You guys, I'm glad you're keeping up with me. So, you're right. I can just add these equations as is. They're already opposite. See, that's why it's actually really important that we think of the objective of each step that we're making as we're making it. So that way, we're not just doing math things to our problem if it's not leading us towards an effective end. So here we'd have y squared. The x's would cancel out. I'd have minus y equals 2. And this looks like it's factorable. I'd set it equal to 0 because notice I've got a quadratic. And often when we solve quadratics, we want to set them equal to 0. Unless I was solving by completing the square. But I don't want to do this because this number is not even. Although it still could work for us. Y squared minus y minus 2 equals 0. And I think this is factorable. Factors of 2 are 1 and 2. Do any of those subtract to be 1? Yes. Yes, wonderful. As a matter of fact, 1 and 2 subtract to be 1. So I'll have a y with a 1, a y with a 2, equals 0. And now I got to figure out what the signs of these terms are going to be. So they have to multiply to be negative, so therefore the signs are different. And they have to add to be negative. So the more influential number, right, has got to be negative. So it'll be a negative 2, a positive 1, right? And when I solve this, you guys might remember that there's the property between the factors and the zeros, or the factors and the roots, where I'll end up getting y equals negative 1 and y equals positive 2. Or it's just the opposite of these guys. But the other way you could have realized that is set y plus 1 equal to 0 and solve. You'd still get the same answer. Y minus 2 equal to 0 and solve. You'd still get the same answer. So these are my two y coordinates, and it looks like I'm out of space. And the easiest way, actually, the easiest place I could plug in to find their corresponding x's is in this equation here. Notice, because then I'm not having to plug into two y values, I'm just plugging into 1, and this is already like almost solved for x. And just to think ahead, I'm expecting that there are only going to be two intersections here. I'm thinking that for a few reasons. One, because I'm talking about a parabola. Actually, I said earlier it was a horizontally oriented parabola, and a line. I could only have at most two solutions, right? So if I found two separate y coordinates, I'm not expecting there to be two y coordinates that have the same. I'm not expecting there to be one y coordinate that have two of the same x coordinate. In this case, it just wouldn't make sense, right? I'm only expecting two solutions. The other reason I'm only expecting these two solutions to each have their own particular x coordinate is look at this equation. If I plug in a number for y here, I'm only getting one answer for x because this exponent is 1, right? Even if I did it up here, this exponent for x is 1. And linear equations only have at most one solution. So let's do this. I might be able to fit it hardly in the side here. We'll see what I can do. So I'll actually even work in a slightly different color just so it stands out from the other work here. So let's plug in -1 for y. So I'll have x plus -1 equals -1. I'd add 1 to both sides, and I'd get x equals 0. All right? So that means when y was -1, x was 0. So there's one solution. The other solution is going to happen when y is 2. So x plus 2 equals -1. Subtract 2 from both sides, I'll get x equals -3. So that means my other solution is -3, 2. All right? And make sure you pair up the correct y with its x, right? I got this x value when I plugged in that y, so I don't want to like mix up which one it went with. So my solutions were 0, -1. I'll write it up at the top. 0, -1, and what was that? -3, it was 2 something. Was it positive or negative? Positive. Right, so here are my solutions, and actually, just so I feel better about myself, let's take a look in the back of the book. Number 19 should have an answer. Some of you guys should already have these bookmarked. Oh, well, you actually have your books at home, I forgot. So your bookmarks would be kept in a nice little space. And we're all the way in chapter 10. I'm looking at 10. Oh, all sorts of stuff. Oh, I found some circles. Lesson 10.8. Warmer. I found, yes, 0, -1 and -3, 2 are the solutions. So it appears as though we're good. Yeah. Voila. Oop, I just messed up the zoom on that. That's okay. So, yeah, looks like you guys have like 25 minutes left in class. So I'm going to have you guys work with partners. I understand it's very easy to get stuck partway through a problem. So just because you get stuck, though, don't just give up on the entire homework tonight. Definitely, attempt every problem because they're all going to be unique. You're welcome to use substitution or elimination, whichever one happens to be most helpful to you at the time. Yeah, so I think we're going to be okay. Monday, we have a review day scheduled, and Tuesday, we've got a test coming up. All right, so we'll have this test. Fortunately, this test is not on too many sections. We actually went through this pretty quickly, so we're moving along at a pretty good clip. So good job, guys. Hopefully I've answered all your questions. Feel free to email me at any point if you have any questions. I will be back on Monday for sure. And actually, also, if you could organize your thoughts and feedback on how well the streaming worked, any ways that I could improve it, that would be great and appreciated. You could either email me those thoughts or we'll talk about them on Monday. just because I feel like obviously my students are my customers, and I want to make sure that I'm, as Mr. Krabs says, the customer is always money. So I'll talk to you guys later. Have a great day, great weekend. Take care. Bye bye.